everyone, my name is Sanjana and I'm a first year student studying in Sri Venkateswara College of Engineering, Bengaluru. In today's video, I'm going to be explaining an important topic from engineering chemistry. So let's jump right into it. The topic for today's discussion is analytical techniques in which I'll be explaining conductometry. So first let's get a brief idea of what is conductometry. Conductometry is a widely used analytical technique that measures the conductivity of a solution to determine its chemical composition. It is based on the principle that the conductivity of a solution is directly proportional to the concentration of ions present. Conductometry is widely used in a lot of industries such as pharmaceuticals, environment testing, and also water treatment, and many other fields as well. So let's discuss a little bit about the principles of conductometry. Conductometry measures the electrical conductivity of a solution by passing electric current through it. Conductivity of a solution can be influenced by a lot of factors such as temperature, concentration of the ions present, and also the condition of the electrodes used for this process. Conductivity is measured using a conductometer, which consists of electrodes and the conductivity cell. Applications of conductometry. Conductometry is used in titration-based analysis to determine the endpoint of a reaction by monitoring the change in conductivity of the solutions used. It is also used in pharmaceuticals to ensure the consistency of the drugs which are produced. And it is also used in environment testing to measure the levels of pollutants in water and soil samples. Advantages of conductometry. Conductometry is a simple technique which requires a minimal sample preparation. It is also a non-destructive method that allows the analysis of a wide range of samples without altering the chemical composition of the samples used. It is also a very cost-effective technique that provides accurate and reliable results. Conductometry also has some limitations to it. One common one being that it can be used only for ionic compounds and not non-ionic chemical substances like organic materials, etc. The accuracy of conductometry measurements can be affected by some factors such as temperature, concentration, and condition of the electrode. Conductometry is also not suitable for the analysis of samples having low conductivities or high viscosities. Moving on. Some of the factors affecting conductometry are temperature, concentration, and electrode condition. Now, for temperature, due to the increase in temperature, the mobility of the ions present in the solution also increases. And due to this, the conductivity of the solution may also increase. Also, the concentration of the ions is proportional to the conductivity of a solution. So that may also produce some variation in the values which we obtain. And the electrode condition also affects the conductivity of a solution due to the electrode may be contaminated or polarized, and due to this the accuracy of the conductometric measurements may vary differently. So now let's discuss one of the major applications of conductometry, which is in titration. Conductometry is commonly used in acid-base titrations to determine the equivalence point or endpoint. This can be monitored by this can be determined by monitoring the change in the conductivity as the reaction progresses. Now, before looking at the process of how the titration takes place and everything, let's first try and understand the instrumentation of a conductometer. A conductometer consists of two platinum electrodes, each of unit area cross section and also placed at a unit distance apart. The electrodes are dipped in the electrolyte solution taken in a beaker, which is connected to a conductance measuring device, which is also known as a conductometer. The titrant is added from the burette and the solution is stirred. The conductance is measured after adding the titrant at 0.5 or 1 ml intervals. So in this diagram, we can see the setup for determining the endpoint of the titration. Over here, we can see two platinum electrodes, these two sheets over here. which are connected externally to a conductometer by metallic wires. We can also see a stirring machine over here to maintain uniform concentration of the electrolyte. And here we have a burette containing the titrant. So to understand the titration using the conductometer, we're going to take an example of a weak acid against a strong base. So for this, we're going to consider the titration of acetic acid against sodium hydroxide. In this titration, on adding sodium hydroxide, the conductance of the weak acid, which is in this case acetic acid, increases until it is completely neutralized due to the formation of sodium acetate, which is a conducting salt. After the equivalence point is achieved, the conductance increases rapidly due to the increasing mobility of the hydroxide or OH ions. And by plotting a graph of the conductance against the volume of sodium hydroxide, we obtain the endpoint of the titration at the intersection of the two curves. So over here we have the reaction of the titration. We have acetic acid and sodium hydroxide as the reactants, and we obtain sodium acetate as the product. This is the graph for the endpoint of the titration. Over here we can see that the two curves intersect, and over here we obtain the endpoint of the titration. Okay, so now that we've reached the end of this video, we can conclude the following points. Conductometry is a valuable analytical technique that offers rapid and accurate analysis of ionic solutions, and it is also used in a lot of fields as we discussed earlier, such as pharmaceuticals, water treatment, etc. And it is particularly useful in titration-based analysis. So I hope you understood the concept of conductometry, and if you found this video useful, please do drop a like and share it with your friends. Thank you so much for watching.